Hello and welcome to iitiansgateclasses once again. Myself Vivek Sharma. I welcome you to the course, and let's start with the pointer and array again. So we have a character array given in this example here. So right now, how you can define a character array? Either you can assign it like something like this, like p, and you can say 10, and you can give here 10 characters like a, b, c, okay, something like this. Or what you can do, you can assign a character pointer to a string. Like this is how I did it. This is a character pointer. This is a string. See the double quotes here in C programming. So this is a string and this is a character pointer. Now, how can a string be assigned to a character pointer? See, the string will occupy space like this in the memory. Okay, G will have a address, A will have a address, T, E, 2023, all have a address. At the end of the string, we will have this end of string symbol. Okay, this is \0. It's end of string symbol. Okay, this is how a string actually allocated into the memory. Remember this. Okay, and there is a very in most of the programming language there is a very important property of a string. I will tell you that also. So now once you assign a string to a character pointer, this character pointer actually pointing out the address of first character, which is G. Okay, so in P we have a variable P. In P we will have a address which is 1000 and P will have some 2000 address. Okay, so this is what this P contains. So once we do star P, it means that we are referring to first character. Okay, now this is what we need to solve, what it will print. Let's see what it will print. Before going to this print statement, I need to explain some of the basic programming property. So along with the data structure, I will be covering programming also. Some concept I will cover after covering data structure. Okay, so here if you see this string, this character pointer actually containing address of the first character of string. Okay, so and this is how a string is allocated into the memory. Each character has some address, and at the end of the string we will have a extra character which indicates end of the string. Okay, now let's see. I have a size of function for like you can see in every programming language. So right now I'm indicating it to like C programming language. We have a size of function. And in the size of function, I am passing the string. Now, what will it should return? It should return actually 3, but right now it's going to return 4. Why? Because we have a extra character which indicates end of character string. Now, if you want to eliminate this, if you want to have actual size without considering this, you have to use string ln, strln, strln function you need to use. Strln function means string length. Strln function won't consider end of string character, this character. Okay, and it will return size as per that. So strln will return us 3, size of will return us 4. Okay, remember this. So sometimes you have to loop through the string, so you must know the size. Instead of using size of, you can use string ln, so that your loop like while loop or for loop, okay, these two loops should not iterate one extra time. Now I have a character array and I am going to assign some value here. I am assigning some value here, some 50 characters here. Okay, then what is the size of A? What is the size of A? It will return us the whole array size, the memory that it's occupying, it will occupy 50 bytes. Okay, 50 bytes actually. So it will return 50 to us. If we consider that each character takes single byte. Remember in the previous video, I explained that how a single integer contains 2 bytes. Okay. Similar to that, in general, every programming language allocate each character. Okay, the type is character. Previously, the type was int. Int was in general takes 2 bytes. That depends upon the compiler. Okay, depends upon the compiler of the programming language. Similarly, the character char, char, we allocate each character 1 byte. Now let's go back to our string, which is gate 2023. Here you can see this G takes exactly 1 byte. That's why the next address is start from 1001 and not from 1002. If we assign integer array, in the integer array, you have seen that, for example, 10, 20, 30, if we assign something like this, then we have seen that here, if we have starting address of 10 is 1000, the starting address of 20 will be 1002 because 10 takes 2 bytes. It's type of int. This type is int. Here the type is character. In string, we have multiple characters, right? Now, if you say that, okay, this 2 is right now a integer. No, it's a character. 2 can be character. 2 can be integer. We have to typecast into an integer also. Okay. Don't get confused into these two right now. Right now, consider that this 2 is actually a character. Okay. Now let's go back to our understanding about the string. And we have covered size of function, strlen function, the character array size. If I do size of on the character array, it will give me 50. 50 means 50 bytes of the memory it's taking. Okay. Now note that whenever you give, how would you pass a string? You, like in C programming language, where you have C or C++, where you have pointers concept. In many programming languages like Java, Python, they don't consider this pointer concept. Okay. It's like they did some kind of abstraction on top of it. Abstraction means you won't get it in the programming, but at the back end, they use pointers, right? Similarly, here also, when we try to pass a string from one function to another function, or we want to print the string, if we pass the starting address, or you can say first character of the string, it will automatically find out, it will automatically try to print the string or fetch the string until we see this sign. So, okay, using some example, I can show you. Previously, you have seen that I was doing print f %d. %d means int type. Okay, I want to print a variable of type int, variable or constant of type int. Okay, here %s indicates I want to print a string. Okay, now whenever I pass this whole string, it will print the whole string. Okay, like gate 2023, it will print the whole string. Okay, there's nothing to worry about it. Now let's consider this string to be saved in memory, something like this. At 1000 we have G, at 1001 we have A, 1002 we have T, E 2023, gate 2023. Okay, we have stored this string into this memory, something like this. So if we know the address of G and we pass this address along with %s, now this function, printf function, is saying that I want to print a string. Okay, I want to print a string. Give me a string. Instead of passing the whole string, you gave the address of first character. Okay, instead of passing the whole string, you gave the address of first character, what it will print. it will print the whole string. Gate 2023. Why it will print the whole string? Because here it's saying that I want to print a string. In printf function, the percentage says that I want to print a string. All it needs is the address from which you want to print the string. Now it will go printing GATE2023 until this end of string character. End of string character is \0. So till \0, it will print all the characters. So what if I pass % as 1003? This is very important concept, right? Right now, instead of passing the string, we are passing pointers, character pointers into the printf function along with printf. Printf says that I want to print a string. 1003 means this is some character pointer. Some character pointer. So it will start from 1003 and it will go till it finds \0. So 1003 is E. From E, it will start printing. It will print E, then 2, then 0, then 2, then 3. And it will stop here at the end of the character string. Now, what if I pass printf %s p? We have seen here in the previous window that this p contains 1000. Okay. This p is, what is p? A character pointer. Not a string pointer. There is nothing like string pointer. It's a character pointer, right? And it contains the address of G. That is why we can assign the whole string into this p, because for a string operations like printing a string, fetching a string, passing a string, all we need is first character address. That's it. After that, it can go till \0. Okay. So this p contains first character address 1000. Now, if I say that printf %s, that means I want to print a string p. It is similar to this thing. Pf %s 1000. Pf %s 1000. It's similar to this one. I have passed 1000 here. So it will start printing from 1000 address, which is GATE2023 until the end of a string character. Right? So this is how I can print strings. So in many competitions and interviews, you find such kind of like questions. They gave you a simple line, okay, like in GATE examination or any other examination, PSU examination, they give you simple one-line question that what it will print. So you should understand that in case of string is nothing but collection of characters in sequential manner. It means that if my string is gate, the first character address is G, second character address will be immediately after G. For example, if G address is 2000, A address will be 2001 immediately after 2000. It cannot be like 5000. Okay. It will be sequential, one after another. Okay. So if G is starting with 2000, A will have 2001, T will have 2002. The addresses, okay, similar to here. Here G have address 1000, A will have address 1001, T will have 1002. That is why we can pass this address 1000. We can pass 1000 anywhere, 1000. Okay, so you can see that not always G will store at 1000. Okay, it will assign random addresses. So that is why we assign a variable to it. We say that okay, character star p equal to, let's take address of the string, which is 1000. Okay, if you don't know the address, we will say that okay, let's assign the string here. It will automatically pick address of G. and we can do operations on it. So let's move on to our next slide where we see more operations. Now, what is p plus 3? Remember, p is a pointer. Now, p is a pointer. In integer, we have seen that once we add something to the integer pointer, it will increase its address based on, you can say, the next number coming up. Okay, next number means the size of integer it will add. Here, the size of character in case of memory, size of a single character is actually what? What is it? Size of a single character is what? 1. Size of single integer, 1 byte you can say. Size of single integer, we considered it as 2 bytes. I'm again repeating it. It depends upon the compiler, but in general, we consider for programming practices, for simplicity also, size of integer to be 2 bytes, size of character to be 1 byte. Okay. So in a integer pointer, if I say that int star something like a equal to some, like we have assigned some integer variable here. Okay. If I say that a plus 2, it means that I am adding, if the address of b is 2000, I am adding 2 pointer address to it. 2 pointer means it will be after a plus 2, it will be 2004. Okay, why 2004? Because the address of next integer will be 2002 and address of next integer is 2004. Okay, because each integer is taking 2 bytes, not 1 byte. Here is taking 1 byte. So p plus 3 would be, if p is equal to 1000, p plus 3 would be 1003. Okay, so I am passing here 1003 using this variable p plus 3. And I'm doing %s. It means I want to print a string starting from 1003 address till end of character sign. Okay, so let's go back and check it. I'm starting from 1003, which is E. Again, it's similar to this thing. So what it will print? It will print E2023. Okay. What does it mean by P plus P3? P3. Okay, let's see in the blank slide here. P3, what is P3? I've explained in integer array that P3 means P plus 3 star. So whatever, this is location, and this whole thing is value at this location. Okay. P3 means P plus 3 star. Okay. So here we want to print a character. It's %c. %c means we want to print a character, not the whole string. At what location? So we want to print a character at P plus 3 star, the value at P plus 3. P plus 3 have value 1003, we have seen it. So it will print E only. Why E? Because at 1003, we have E only, E character. And we are printing, %c says that we want to print a character. Now, what if we do P plus 3 star or P3 here, and we do %d? What does it mean by %d? %d says that we want to print an integer, but we are passing a character here. Character is E. We are passing character E. Why E? We have seen here. Okay. P3 is P plus 3 star, and P plus 3 star will give us an character E. So if we do something like P printf %d And here, if we pass a character, what it will do? It will actually print ASCII value, ASCII value. So this is an standard for characters. Okay. For each character, we have a value. For example, if I try to find ASCII values, let me show you the ASCII value for alphabets. Okay. ASCII value for alphabets. So it is international standard, which is accepted by all around the world, that A have ASCII value 97. Okay. B will have ASCII value 98, and it will go till Z. Okay. Something like this. And Z will have ASCII value 122, I think. Yeah. Now capital A have some ASCII value 65, and it will go till Z. Capital Z have some ASCII value 90. If you search ASCII value on Google or any of the platform, it will give you ASCII values for each character, even the space bar have some ASCII value. And these ASCII values are in form of integers. Space bar has some ASCII value. Okay, I'm not sure what is the ASCII value, because you don't have to remember all the ASCII values. You just have to remember ASCII value for small a to Z, capital A to Z, and 0 to 9. 0 to 9. You have to remember. Okay. So each character, I'm talking about character, these 0 to 9 are not integer. I'm talking about this like 0, 1. Single quotes indicates characters. 2, 3, like this 9. So now you can see that this gate 2023. If you pick single character, this 2 will be represented like this. It have some ASCII values. So once you print integer, you want to print an integer, and here you pass a character, it will print ASCII values, not E. It will print ASCII values. What is the ASCII value of B? C ASCII value is 99. D ASCII value is 100. E ASCII value is 101. It will print 101. Okay. Here in the print statement, whatever you pass here, it says that PF %C. I'm specifically talking about C++ language. PF %S. This is what the type that we want to print. Type. Here we pass the value, any value. For example, previously we have passed address here, the value also, for example, P3, something like this, or P plus 3 star we have passed here, right? So if the type is of type integer, int, and we pass a character here, it will print ASCII value for it, ASCII value for it. If you pass a character here, it will print the character. If you pass a string here, it will pick the pointer. Here we pass a character pointer. So it will keep on printing, starting from this character pointer, it will keep on printing till it find a character of sign this %0, which indicates end of the string. Okay, now we are ready to solve this question. Okay, so let me go to a new window. Here I will write down again our array GATE 2023, and each character has some value. We also have \0. Okay, suppose let me use some other color. We have suppose it's at 1000 location character, and we are assuming that each character is taking exactly 1 byte. So the next address, and the address is byte addressable. Okay, this is what our character, and we have given with a pointer that star p equal to this string. So this p will contain the address of first character. Okay, this is 1000. It's character star p, and we assign this string to this character pointer. It means this pointer contains address of first character. Okay, now what do we need to solve? We need to solve this question. P percent s p plus, sorry, p3 minus p1. This is what we need to solve. So how do we solve it? This p means address. Address is 1000. What is p3? p3 means p plus 3 star. P plus 3 star. It means value at p plus 3. Value at p plus 3. What is p plus 3? 1000 plus 3. 3 means increasing to the next pointer, then next pointer, then next pointer. Okay. So p plus 1 is this one, p plus 2 is this one, p plus 3 is this one, 1003. So at 1003 we have E. Okay, E minus P1. So it's P plus 1 star. Okay, so this is P plus 1, star means A. So can we subtract two characters? No, we cannot subtract two characters. Whenever we have two character subtraction, we actually will do ASCII code subtraction. So I have told you here that what is the ASCII code of A? It's 97. 97. What is the ASCII code of E? It's 101. Okay. So it is actually 1000 plus 101 minus 97, which is equal to 1004. And we are actually doing P percent S, P printf percent S 1004. Okay, 1004. So we will print the string starting from 1004 character address. 1004 is this. It will go from 2023, and once it finds this, it will stop. So it will print 2023. This is the output. Okay, this is the output. I hope this clears that how a string operation can be done using pointers. Okay, now let's move on to a very interesting example here, which is this one. Note this down. Note this example down. And I am repeating this example. We have a integer pointer, integer array A. It contains value 10, 20, 30, 40, 50, and 60. Exactly 6 values. Then we have integer pointer array, star B, and this sign says that it's an array, right? This sign says that it's an array. And once we do int A, it means that this is an integer array. Once we do int star B, it means that this is a integer pointer array. Integer pointer array. And we have seen that what is the value of A. Suppose this is stored at 1000 location. The value of A is 1000. So what is 1003? We will see. What is 1003? What is A plus 3? What is A plus 5? A plus 1, A plus 4, A. So this contains integer pointers, array of integer pointers. Now we have a star C. It means that this is a integer pointer. It is a pointer to pointer of type int. Pointer to pointer type int. In the next line, it's star C plus plus. Star C plus plus. In the next line, we want to print C minus B, comma, star C minus A, comma, star C. Then we did plus plus C. Then again we print this same line. C minus B, star C minus A star star C. Then we did plus plus star C. It's plus plus star C. Okay. Then we did C minus B star C minus A star star C. C minus B star C minus A star star C. Okay. Now let's start with this program. Keep it handy in your notebook, and we are going to create some arrays. Initially, we have array A. Okay. It contains value 10, 20, 30, 40, 50, and 60. Okay, let's give them address. We know that integer contains 2 bytes. We are assuming it contains 2 bytes. In general, it's 1000, 1002. So next address will be 1002. Next address will be 1004. It will be 1006, 1006, 8, 1010. Okay. So what is the value of A? A is a pointer actually. It's a pointer of starting address, which is 1000. Now we have a array stored in B. Stored in B means B contains the starting address of the array. Starting address of the array. Okay. Now here it will clear very important concept. So this is B. We array have actually here. Look here. B array is A plus 3, A plus 5, A plus 1, A plus 4, A plus 2. Let's write down that first, then we assign the value as per these values, like 1000, 2000. So B is actually A plus 3, then A plus 5, A plus 1, A plus 4, and A plus 2. This is what B is. So in terms of values, A plus 3, what is the meaning of A plus 3? Right now, A is 1000. What is A plus 1? A plus 1 actually 1002. The pointer to the next element is 2. Because each plus 1 is actually next integer address. Next integer address, as integer size is of 2 bytes, so we have to jump on 2 steps. Okay, not 1 step. What is A plus 2? A plus 2 is 1004. A plus 3 is 1006. A plus 4 is 1008. A plus 5 is 1010. Okay. So A plus 3 is what? 1006. A plus 5 is what? 1010. A is 1000. A plus 1 is 1002. A plus 4 is 1008. A plus 2 is 1004. Okay. And we are also going to give addresses for B. It's actually star B, you can see. Okay. It's B, and we have assigned B int star B like this. So B is actually a pointer to pointer. B is actually a pointer to pointer because B contains pointer addresses. Remember, in general, like right now, I don't know about compilers, but previously, each compiler assign pointer into a single byte, or you can say 8 bytes, sorry, 8 bytes. So size of integer, we assume that it's 2 bytes. In general, we always consider 2 bytes. Size of character is 1 byte. Size of pointer is actually 8 bytes. 8 bytes, and these are pointers. This is a pointer. This is a pointer. This is a pointer. This is a pointer. Pointer. So it's 8 bytes. So if I consider that its address, starting address is 2000, what is the starting address? I am going to use green color for this also. Now, its address is 2000. What is the address of this value? It's actually 2008 because it's containing pointers, integer pointers, and integer pointers we always consider it to be 8 bytes. Here integer pointer contains integer. Here integer is of 2 bytes. That's why the next address is at 1002. Here it is actually of 8 bytes. That's why next address is of 2008. Next is, what is the address of next value? It's actually 2016. We are adding 8. 2024, 2032, 2040. So this is how address works. Because each value is of 8 bytes. That's why the next address is 8 greater than the previous address. Now what we say that in our program, we say that star C equal to B. Okay, it means that what is the value of B here? B is actually 2000. Starting pointer value. Starting pointer value is 2000. And we have seen that star C equal to B. So C is actually 2000. Okay. If we are clear till here, we can move on to our print statements and statements that are given in the program. The next statement is star C++. Now it will, this very small statement solves many problems here. You will understand two main concepts. Okay, first is, remember, once you have only one operand, this is operand, this is operator. Okay, like A plus B. These two are operands and this is operator. Okay, these two are operands, this is operator, like A star B. These two are operands, this is operator. So once we involve two operands, it's called binary operation we are doing. Well, this is a binary operator operating on two numbers. If it operates on single number like C++, it's called unary operation. Okay, and remember that always unary operation precedence is greater than, always greater than binary until you apply quotes. So for example, if you do plus A plus B, this will always be operated first. First, the value of A will be increased by 1, then these two will be added until you do this, like A plus B plus plus. Then in that case, this braces is saying that, okay, specifically operate this one first, then increase its value. Okay, so you remember there is something called precedence. Once we have multiple operators, we have some precedence. And you must have seen many examples on reels or on social media that somebody give you a question like 3 star 4 plus 5, what will be the value? And many people guessed it wrong because this multiply, which is a binary operator, plus is also a binary operator. Multiply have greater precedence. It means that multiplication will always be evaluated first until we apply braces. In this case, plus will be evaluated first. So if you do like 3 star 2 plus 1, in that case, what will happen? It is 6, then plus 1, 7. Right? If you do like this, it means that we are specifically saying evaluate first, 1 plus first. Okay, so this is 3 multiplied by 3, which is 9. Okay, so this is about binary operators. Now, once you are given with unary operator, now here, remember, let me erase the whole board. And here we are given star C plus plus. Both the operators, both the operations, both of these operations. First one is this one. This is one operation, this is another operation. Both operations are unary. Because they are operating on single operand, which is C. They are operating on single operand. Then what will happen? In that case, what will happen? Pause this video and try to guess the value. We know that C have a value. C have a value here, which is 2000. 2000. C have this value, 2000. Now try to guess the value of C after this operation. It is very interesting, right? If it's clear conceptually, you won't hesitate to answer it. Okay. If you guess the answer, that's very good. Let's move on to it. Like right now, what will be the value of C? Star stars, we have star, which saying that go to this address. Go to this address. Okay. Plus plus means increase the value. So what will happen? Either the value of C will be increased first, and we will go to that. We will go to that value, or we will go to that value first and then increase the value. So that's what remains here, the like mystery. Okay. Now remember this. In case of unary operators, the associativity. What is associativity? For example, if I write 4 star 5 star 7, here the associativity is left to right. Left to right always. In case of multiply, divide, plus, minus, generally until unless it's mentioned in the question that associativity is right to left, you always consider that these operations, star, divide, plus, and minus. Once you have something like this, 4 plus 5 minus 7. First, this plus will be calculated. Okay. First, this plus will be evaluated 9 minus 7, which is 2. Okay. It may give you the same answer, but the computer, your compiler will evaluate this first, this one first. Why? Because the associativity is from left to right. First, the left operator will be calculated, then the right one will be calculated if both are at same like precedence, right? We know that in case of star, like star means this multiplication, 4 multiplied by 5 minus 7. Here we already know that, okay, it doesn't matter, 4 minus 5 star 7. Here it doesn't matter because the precedence of star, this multiplication is greater than minus. That is why we don't have to consider associativity. Associativity comes into the picture once the precedence of operators are same. Here the precedence of star and plus plus. This star is not same as this star. This is multiplication. This star is go to the address, go to this address, whichever C provides. It's from right to left. Right to left. Okay. It means that the right operator will be evaluated first. So we had two options here. In case of star C plus plus, we had two options. Either go to this address, then do plus plus, okay, or either do plus plus first, then go to this value. Okay, so what did we choose? We choose this one as correct one because the right operation in case of star plus plus, this is the right one, this is left one. In case of unary, remember this, note it down. Until unless it's mentioned separately in the program that associativity is from left to right, you always evaluate right one first. It is known that in case of unary operations, associativity is from right to left. Okay, right to left. So this one will be evaluated first, then this one. So we do C plus plus. What is the meaning of C plus plus? C plus plus means, actually the meaning of C plus plus means C equal to C plus 1. This is the easier way to write actually, C plus plus. C equal to C plus 1. Now go to our program and we say that what is the value of C? 2000. Now, if you do C++, what will the value of C? It is not 2001, remember. It's a pointer to pointer. So we increase its value by 8. Why? Because here the value of this pointer is actually 8 bytes. So once we do +1, it increased by 8. Okay, so C++ is actually 2008. So here this value will be replaced by 2008. Okay, 2008. Let me erase irrelevant values from here. So we have done star C++. See how much time it took just to explain star C++. Why? Because it's very important in case of unary operator, associativity, precedence. Precedence means which operator is more important, or you can say which operator have higher priority. So after doing this step, till now we have evaluated. Okay, let me clean this board. This one, and this one. Okay, till now we have solved till here. Okay, till here, the value of C will become 2008. And once we do star, it doesn't mean anything. We are just going to the value and checking it out. We are not printing it. We are not increasing it. We are not doing anything. Okay. Now let's go to the next operation, which is what? This one. Printf C minus B star C minus A star C. So what is C minus B actually? C minus B. What is C minus B? This is also a very important concept now. That is why I picked this question, okay, from my notes. So let's clear this. We are doing C minus B. The value of C is actually, let me use some other color. The value of C is 2008. The value of B is 2000. Okay, 2000. These two are addresses of addresses. Address to address. Okay, these two are addresses actually. Pointer addresses, not integer addresses. These two are pointer addresses. Okay, if you remember, here we have seen that this is integer address. Okay, and this is a pointer address. Right? What is the size of pointer? It's 8 bytes. That is why whenever we increase the value of a pointer, it increases by 8. We have seen that C equal to C plus 1 actually. Initially C was 2000. After C equal to C plus 1, it becomes 2008. Okay. Similarly, what if we do C equal to C minus 1? It will become 2000 again. Okay. Similar to that, if we do C minus B, C is 2008, B is 2000. Somebody says that, okay, its answer is 8. No, its answer is not 8 because the type of this operation is pointer, integer pointer address. So after doing 2008 minus 2, the value 8 will be divided by 8. 8 will be divided by 8. And it will give us 1. Why 8? Because size of integer pointer is 8. Size of integer pointer is 8. So once we do 2008 minus 2000, here the value will be 8, not 8. 8 divided by 8 equal to 1. Interesting, right? So 2008 minus 2000 will become 1. So somebody consider these things as tricky questions. These are not tricky questions. Once you understand it conceptually, that actually each operation plus minus, actually plus or minus, we are only considering plus or minus. Okay. In case of plus or minus, whatever value we get, that value should be normalized. Normalized by how much? The size of type. type of this is integer pointer, type of this is integer pointer. Whatever value we get, we divide it by the size of this type. Size of this type is 8 bytes. So we divide it by 8, we will get 1. Now let's move on to the next operation, which is what? Which is star C minus A. We have done this, star C minus 8. Now what is A? A is actually 1000 here. Star C. So first, let's see, what is C? C is 2008. Star C means go to 2008 and let's check the value. Go to 2008. 2008 is what? 2008, it's 1010. So it's actually, star C is actually 1010. And we are doing star C minus A. Now remember this. In case of star C minus A, this is a binary operation. This is a binary operation. This is a unary operation. So always the precedence of unary operation. Precedence means the priority. We give more priority to the unary operation. So in star C minus A, first this will be evaluated, then this will be evaluated. Okay. First this will be evaluated because precedence of unary operation is always greater than binary operations. Okay. So I hope it's clear. So that is why you calculate star C first. What is star C? It's 1010. What is A? It's 1000. So once we do 1010 minus 1000, now guess the value. After subtraction, what will be the value? Here the value won't be 10. It is 10 divided by 10 divided by how much? The size of each integer. The size of each integer is 2. Why did we divide by 2 here? It's actually 5. Because this is of the value of it is integer pointer. Okay, this is integer address, not integer pointer. This is integer address. Okay. And each integer is taking 2 bytes. Each integer is taking 2 bytes. 2 bytes. Okay, that is why we divided by 2. In the previous one, where we did 2008 minus 2000. 2008 is address of integer pointer. This is the address of integer pointer. That is why we divided by 8. 1010 is address of integer. 1000 is address of integer. And integer size we already considered as 2. That is why we divided by 2. Okay, so answer is 5. Let's move on to the next value, which is star C. Star C. What is star C? It is like C, we have 2008. Okay, and go to 2008, star C. Star C is what? 1010. Okay, 1010. Then go to 1010 and print it. 1010 we have 60. You can check it out. 1010 we have 60. So it's not 1001, it's 1010. Okay. It's 1010. Okay. I hope that you can solve the further question, like remaining question. Till here, all the concept should be cleared. Okay. So let's try to solve again the remaining part. In the remaining part, we have plus C. So we are increasing the value of C from 2008 to what? We are increasing the value of C. So C will be increased from 2008 to 2016. Again, we solve the whole question. I will solve it one more time. First operation is C minus B. Second is star C minus A. Third one is star C. Okay, star C is easiest one, so let's solve it first. It's saying that 2016. Go to this address. Go to this value 1000. 1000. Go to this address 10. So it will print 10. 10 here. It will print 10 here. Okay, 10. Then what will be the value of C minus B? B is what? B is 2000. C is 2016. So 2016 minus 2000. Okay, the answer is 16 divided by 8. Why 8? Because that address which is indicating it's integer pointer address, right? At 2016, what are we storing? We are storing a address, integer address, and address is of 8 bytes, 8 bytes, right? 8 bytes. That is why we divided by 8. So it's 2. Now, what is star C? Star C is 1000. 1000. What is A? A is 1000. So answer is 0. Okay. Similarly, you can solve the next question also. In the next step, we are actually doing plus star C. Okay, we are doing plus star C. Now it's right associative, right? So first star C will be calculated, then plus will happen. What is star C? Star C, right now C contains 2016. 2016 is this one. So we increase the 1000, this value, by a plus. We are doing its plus. So we increase its value from 1000 to 1002. Okay, why not 1? Because this 1000 is integer pointer. So once we increase +1 here, we do +1 here. Here, this plus star C means actually star C equal to star C plus 1. Okay. Star C equal to star C plus 1. Star C is actually what? 1000. So we do 1000 plus 1. Now 1000 is address of which pointer? Integer pointer. In integer pointer, if you do +1, it will be increased by 2 because it contains integer values. Integer values is of 2 bytes. 2 bytes, right? I am repeating same things again just to clear the concepts. Now this value will be increased by 2. And in the next thing, what we will do C minus B and star C minus A, star C. So the star C will remain same because we haven't changed the value of C. Okay, the star C is 2016. Go to 2016, it won't be same. Okay, go to 2016, go to 1002. 1002 we have 20 value, 20. So it's 20 here now. What is C minus B? B contains 2016. C contains 2016. B contains 2000. And 16 by 8, it's 2 again. Star C, what is star C? It's 1002 minus 1000. So it's 2 divided by 2, actually 1. Why did we divide it by 2? Because this is of integer pointer, which contains integer values. An integer is of type of 2 bytes. So the answer is 1. Okay. So thank you all for joining. I hope this clears your pointer concept. We are done with the pointer. And if time remains, I will solve 2D array questions. I will pick 2D arrays pointer questions, like how can we refer to a row and column, that I tried to explain yesterday. I did a small mistake there, but the concept was same, right? Once we do in 2D array like A, 2, 4, what does it mean? It means that go to the second row and do +4. So we do +2. This A plus 2 means its A is actually right now pointer to pointer. Pointer to pointer. Okay. So pointer to pointer means we have rows stacked like this. Okay. Go back. So in 2D array, we have rows like this. Rows. This is first row, this is second row, this is third row, this is fourth row. So here a pointer indicating first row, which is, for example, at some address, and a pointer indicating second row, third row, fourth row. Once we do A plus 2, actually A is right now here. A plus 2 will move on to here. A plus 1 is this, A plus 2 will here. it will jump on to the third row. Okay, from first to third row. Then we do star. Star means we have selected this row. We have selected this row. Then we do +4 and then star. +4 means go to the fourth address. Go to the fourth address and print its value. This is how we do 2D array operation. So obviously, okay, it's not our time. This, I think 2D array concepts are important. It is also asked in many examinations. So I will explain few examples in 2D array. Then we move on to our next concept, which is structure and union, which is fundamental for a linked list and tree. Okay, because in C and C++, the structure union are made, these linked list and trees and graphs are made from structure only. Okay, so you have to understand the inner concept of the structure, how structure works. How can we link a node to another node, like in tree or a linked list? How can we make nodes and links between them? That is a very great idea. So let's see that tomorrow. Thank you all for joining.